Hi fam, how's it going? I'm Steven, and this is a long video for a class so I don't fail. This is C++ tutorials, and let's do this. The first thing we're going to talk about is the stream. And the stream is basically an abstraction that represents a device on which an input and output operations are performed. So, for example, in this case, on the C++, on the IDE or the integrated development environment, the input would be the keyboard that we're typing on. The keyboard takes inputs from each key, and it would, if you put a number or maybe a letter in, it'll take it in, and when the program is run, it can, or maybe it will, output whatever you put in. So if you put maybe math, 1 plus 1, it will put 2 out. Or if you put hello world, the output would be hello world on the terminal or console. So then we go to the next slide, which would be CN and Cout. The basis of CN and Cout would basically be the same thing as stream, in where CN takes in inputs from your keyboard and is able to store it into variables, which we'll talk about later, while Cout is basically taking the variables or numbers or letters or even words that you put in and outputting it out to the terminal itself. Now that's we go to the next one, which is variables, and variables are basically names for data on computers. So if you want to put numbers or words, you gotta assign them to a name. This is so you can call on them later when you need it, or if you want to save something onto it. When you use variables, if you include characters that are not allowed, it won't let you to use these names for them at all. So the variables itself need to contain, well, they don't need to, but they can contain letters, digits, and the underscore character. The first character of the name must be a letter, and the only things that are not allowed would be like the number sign or exclamation marks, foreign characters that are not of the English language and all that. So we're gonna go on to Visual Studio Code, and we're gonna basically test out or show some of the examples of just using CN and Cout and naming our variables. And along with variables, we're going to go into data types. So basically, we're going to cover stream, the CN and Cout, and along with the data type and variables. So first things first, we're going to open up a new C++ file on Visual Studio Code. You can find ways to install it on your preferred device on the internet, but for now we're going to focus on figuring out how these things work. So if you want to, when you start off a code, the first thing you got to do is make a new file, which we have here already. I named mine meme, and you end it with the .cp extension, which is the C++ file format. Now, the first thing first we gotta do is type in our header, which would be hashtag include, and it'd be IOStream. So with IOStream, this one basically allows us to put the CN and Cout commands in. Without these, it won't work, so it's really important, since if you're trying to take in data from the computer and you're trying to output stuff. Now the next thing we're going to include is using namespace std, and we'll cover this later, but for now it basically allows us to name our variables. And the next thing we're going to put in is int main, and we put the parentheses, and you put the curly braces, and then we put in return 0. Now this is a basic code, like the raw elements of a code is. Int main is basically your function, which we'll talk about later, but it's basically the thing where your code will be, and the computer will take stuff in and run it. The return zero ends the code, and that's the general idea of it. Now we're gonna go over C in and C out. So C in is we'll put we're just gonna put a variable. For now, we're gonna just put int, which is an integer, but we'll go over that also later, and we'll name it hello. Okay. We're gonna put cin and put hello, and that means we're gonna take whatever we put in. So cin allows us to take things from the keyboard. So when we run the code in general, what's going to happen, it's going to give us a bar on the bottom in the terminal over here, and it will let us type it ourselves. And once we hit enter, whatever we put in will be stored in for hello. How to output that would be cout, and you would basically put cout hello. So we have all these in place, and now we want to run them. So on the Mac side, what you want to do is you want to put in on the bottom G++, and then the name of your code, in this case meme.c++cpp. Now you hit enter, and then it'll run it, and if there's an error, it'll show up, but in this case everything's clear and it went through. So what you have to put in next is to put ./a.out, and this basically takes the code and it will run it, and it will display on the bottom of the terminal. So we put cin, and it goes to the hello, so it makes us want to type what you want to put in, and it's an integer. And integers are basically just numbers. We'll go over that again. So it's an integer, so we're going to do maybe 10. So if we hit enter, cout will display 10, and that's the code. And that's your first program. That's pretty cool. So what we're going to go next is we're going to talk about the different types of data types for the variables. Now in the C++, there's a small amount, so we're going to go over it real quick, which is basically integrals, or for short int, float point, which people use, and then there's also decimal and boolean, but there's more like char and then string, but for the most part it's going to be int and then float and then boolean, char, string. The difference between float and decimal is just to basically sum it up, it's integer is whole numbers, so you can't have decimals in the middle. That's basically what it is. There's float point and decimal, which are basically the same thing. The difference is that the decimal and float have different limits. So one of them can't go at to 30 trillion, while one can go to 20 trillion, or so on and so forth. The next one would be Boolean, which is in Boolean math. It basically goes to like binary. So binary is just 1 and zeros, and that's how it is. That's how all computer code is. And Boolean basically sums it up to the raw elements of 1 and 0. So if you put Boolean, it's either 1 or 0, and you can do Boolean math with the operators later on, but for now we'll keep it simple. There's also char, which is just characters. You can it's one letter number, and we have string, which is either a full word or a group of numbers. But if it's numbers, it won't act as an integral or a float or decimal or so forth. So to test out the variables, we're gonna copy something I made earlier, and we're gonna see how these things work out. So we have the basic structure of the code, but inside we have int, double, float, and we have names of them, and then we have something that's output them out at the end. So as you can see, hello is 12 because it's a whole number, high and float. And yes are double float, and they're decimals. A string is plain, and a string is basically just a phrase, a word, and that's what it is. And then we basically output them. So we're gonna clear the console. We're gonna go save it, and we're gonna print it out. And when we print it out, we should be able to get the same things we have from top in a line. And that's basically what it is. That's your idea for variables, and then C in and C out, and we're done for that last one. And for the next one, we're gonna go towards operators, but we'll see you after this cut. So now we have operators, and operators are used to manipulate information. So these can perform actions such as addition, multiplication, or comparison, and so on. So there are different types of operators in general, which include relational and logical operators. So relational is basically used to compare numbers such as equal or greater than or less than. While logical is based off true or false due to the Boolean logic. This involves using zeros and ones to put together, like 1 and 1 or 0 and 0, and have an outcome, and it will display whether it's true or false. We will now go to Visual Studio Code, and we'll do some examples over operators and learn more of how they work in different environments. So let's go and talk about operators. In this case, we have the assignment operator, which is the equal sign here, and we have ya equals 9, yeet equals 2, and we have the addition, subtraction, and division. There will also be division somewhere else, and for this one we have multiplication. We also have the modulus one. So 9 plus 2 would be 11. 9 minus 2 would be 7. And we have yeet, which is 2 times 2, which is 4. So 9 divided by 4 would give us the remainder of 1. So we're gonna run this one real quick, and we go for it. So 11, 7, 1. And that's basically the first operator, which is the arithmetic, which is just basic math. Now we go to the next one, which would be the relational, and would be the relational would be the greater, equal, or the least than equal to. So in this code, we're trying to we get a number, and it would basically put the number, if the number is greater than or equal to 0, and number is less than or equal to 100, it would output yes. And if it's anything else, it would put no. So we're gonna go into here and type in greater than, let's see, PP, and we hit that out. So if we put the number 10, it's gonna give us yes. Now the code is specifying between a number 0 and 100. So if we go to maybe -10, it would give no. We do it again. We do 101. It's no. So it basically allows us to specify the range of numbers and gives us different choices on our input in general. So for the one we talked about earlier, the grades, if the core, like I guess the number, you put a number in, and if the number is above 90, it'd be a 90. It would show it 90, because we can put individual statements from the ifs. And if you want to just put out the next grade and next grade and so forth, we go on, and then else, anything else past would be an F. So this is a good way to break down like a structure. It shows pathways into something else. So now we'll be talking about statements, and there's two types of statements, which involve conditional and loop statements. Conditional is basically using if. So for the most part, it's using operators and if. The variable is a certain way, they'll diverge into different outcomes. For loop statements, there are different types of loops. Loops, as the name suggests, are statements that repeat or loop over and over again. So the difference between them change how they work. we'll go over more examples in Visual Studio Code, and we'll see how these ones work. But in general, what it is, it's like it's choices. Conditional involve like something to happen. So if to go in depth, say we have a code that has grades from 100 to 0, and grades work A, B, C, D with 90 to 100, and then 80 to 90, and so on and so forth. So if you want to have an A, it should be a 90 and up. So if grade is greater than 90, you have an A. If you have a number like 80 to 90 would be a B. So it'd be, if grade is between 80 and 90, we should be using two very relational operators together, which involves having the number being greater than 80, but it has to be less than 90. And that's how it works, and so forth and so forth. So that's how a conditional statement works. While so for loops, it's basically saying if this, if the plane is in the air, it will keep doing this program over and over again until the status of the plane is different than what it's asking, and that's basically how loop statements work. And let's get into the code itself. Signals now. So we did examples of these in the operators, but let's do this again. So we have another code. It's basically saying put in a number, and if the number is least than 10, it'll do no, and if it's higher than 10, it'll say yes. So let's just put in the name with G++ on the bottom. Let's run it, and let's put the number 5. This number and it gives no. So let's try doing it again, and then let's do it again because it sort of bugged out. So put 5 and it gives no. We do it again. We'll put 20 and it'll give us yes. So this one basically puts, if it's less than 10, then it doesn't do anything, and if it does, then it'll put something else. Or what I say, it would output no if it's less, and if it's higher, then it would do 10. Let's move on to the next one over here, which would be a loop statement. So from the conditional, we can see that it's an if and an else, and if you want something else to be else if, and it's based off the numbers in between the parentheses here. Now the difference between this one and this one, the other one, would be a while. So basically what happens is you would want to put something in here like maybe if it was true if you're using Boolean, but in this case, as long as I is least 10 or equal to n, and we can put n ourselves, say if it's 10, if I is not equal to 10, then it will keep going. The statements in here, the code in here will keep going over and over again until it hits 10. And in order to finally get to 10, you would probably have to have increments for the letter I, and since I is 0 here, every time it runs, I will be given 1, and then 2, and then 3, and 4, and 5 until it reaches 10. So it's basically, let's output this code real quick, and we'll see how this one works out. It ran, so it didn't have a break, so we hit that out, that slash that data out, and then we put in a number. So let's put 10. And what this code basically does, it counts from 0 all the way to 10. How this works is we put the number 10, so if I is less than or equal to 10, it will output an I, and I is 0, so it goes from 0 and then adds 1 and repeats again all the way up to 10. So loop statements are basically like a test for over and over again until it reaches the point. while conditional is more of if the number is this, then it'll be this. Yes. So we're gonna go on to the next topic, and the next topic is gonna be arrays. So what arrays are is they basically create lists, and you can define how long the list is, and you can store different variables within the list. To be more precise, of what arrays are is they're a type of data structure that can basically store information, and it starts off from you can specify the range. So if you want it to be 10 spaces, you can just put 10. Well, what it how you define it, we'll go over in the Visual Studio Code, but you basically rather than putting multiple iterations of this, something like, say, grade 1, grade 2, grade 3, grade 4, in like if you by like initializing it, you can basically put them under one category like grade, and then you can put each of those grades into different sections or elements from the first to last, and that's how it works. Have the array. This is an array example in Visual Studio Code. So what we have is we have an array up here, and it's defined here. So it's an integer, so it's going to be only whole numbers. This is the name of it, which is yeet. And between these are like brackets. Now between the brackets allow you, like we said earlier, these specify how long the array is. So if it's, since it's 5, the array contains 5 numbers in it. We don't know what they are because they haven't been defined on the side. So this allows us to, in this case, we're gonna be able to put numbers into the array and save them as it is. Now we have two fours here. We have the 4 and 4 here, and this we did this earlier, which basically since we put int I equals 0 and I is less than 5 and I plus plus. So we're basically, it's going to repeat until it hits 5, since it's going to add 1 to it every time. So it's basically going to ask us to input a number, and it will save the number into I, which is at this time 0, and then it'll add it to the 1 slot next, and then the 2 slot until it's done. The thing is, since it's at 5, the array is 5. The range is 0 to 5. We do to 5 max, and if you overpass this, it will save it to a space that doesn't exist, so it just won't work that way. Then we have cout array, which just puts the array in, and the bottom one is sort of the same as one on top, but rather than storing the variable or the number into the yeet array, it's going to output what we had before. So it's sort of the same thing. Now let's try it real quick. We're going to compile it, and we're going to run it, and now it's going to ask us for our input. So we're going to just do 10, 20, 30, 40, and then 50, and that's 5 times, and it should give us array and then the numbers before. So this shows the array works, and that's that. For the next subject, we're going to be going over functions. So we've already gone over functions before in the basic codes, because when you type out a code, you have your header and then you have your using namespace, but then you use int main, and int main is basically a function. But you can also make other functions that can perform specific tasks. Say you want a function to take the numbers and multiply them or add them, and rather than putting it all in the main function, you can pull upon the adding function or the multiply function, and you can basically input numbers in, and it'll do the whole task on that separate function out there, rather than putting it in the main one, so you don't have to type it over and over again. So into functions, you got the function prototype and header files. And what function prototypes basically are the idea or the concepts of what the function will be. So rather than putting all the significant variables in, you're just putting that it's going to be maybe a void type function or an int type function. It'll have this many inputs in, and that's what it basically is. And you also name it in that stage too. Usually you put these on the very top of the code, maybe above your main your int main, or maybe after you're using namespace, but that's what it is. Along with this, you have a header file, and these are basically external files, not on the C++ file, um, but somewhere in a nearby folder in the same directory, and they usually have a .h extension. They basically contain code, um, usually like functions on them that you can pull from the main code, the main file that you're using. Rather than having everything on one, you can use these in different ways, such as like a function. Rather than having everything on one file, you can pull upon these for different uses. Say you want to have another code that does a specific task. You can, rather than typing it again in the main code or in a function on the actual code itself, you're just pulling it up from another file. So the functions basically make it easier to perform your task, um, and they simplify and compress the size of your files. And this is a basic function where it gets one integral and the other integral, and and it gets another integral, and it puts it together in the one on top, and it puts it together and gets the sum of it. So this is the function prototype, which basically shows what the function will be. So it's a void, and this is the name of it, which is sum. It takes in the variables a and b, which we can put later on down here in sum, parentheses a and b. So in a and b, and we don't know what that is, cout tells us to put it in the first one, so it's to a, and this one goes to b, and you put it into the function. Now it goes from here, and then it'll go to the one on top. Now once it's the one on top, it will basically run this whole entire situation. So it's going to make a new line, and it's going to just do a plus b, and it's going to print it out. That's all that it does. So if we compile it, and we run it, we put in the first number, we'll put 5, and we'll put 23, 5, 6, 7, 8, 28. And that's functions. The next section we're going to be going over are strings. And what strings are they're basically arrays, but rather than using numbers, they're using text. The text can contain numbers, but they won't have any value at all, and they're basically just letters. The main reason why people would be using strings is they're really useful for communicating information from the program itself to the user. Although this is good for communicating information, it's not good for storing information itself. We will now go to Visual Studio Code, and we'll do an example covering what strings are and how they work. We'll be working on strings. Now, this is the first example, and this is what else you can do with arrays. What we have is a array called color, and we have a list of animals. Now, what this one on the bottom does is it basically takes the stuff from the array and it prints it out like normal. And this is a string type array. So if we were to here and we were to compile and we would run again, it would display, it should display the animals. Yes. Now, we go to the next example, and this is an actual string. And what we would see is it has character name 20. So the string name has 20 from 0 to 20 range, and it's a character based. Now we have count, which is from 0, and that's our counter. And we have the phrase, please input your first name. Now, characters come at one at a time, and this is how we take in the information in. So sin.get name 20 specifies we're going to be getting the inputs from the keyboard and putting it into name, and we know that it's has from 0 to 20 range, so that's what it is. Now, for the next one is it's going to see if the characters from the array or string, we're going to see if it's equal to 0, because the way to end or terminate or distinguish when a string ends is by the /0 or the null. Now it's going to basically count from 0 to 20, and if it has, say, a character, like for my name, Stephen, STEPHEN, after N would be nothing, which is 0, and that's when it would stop repeating and it would start inputting it out. If we were to test this, we would put it in, and then we would run it, and then all we got to do now is wait for it to say the first phrase, please input your name, and then we put our name in, and what happens is it's going to count how many letters are in our name. That's what it does. And it does this by getting the total amount of numbers from the range, which is 20, and it will subtract it by the number of letters in our names. And there's also a little extra stuff on the side, but it works. Now, if we were to run out the game and again, and we would put someone else's name, say Tim, the amount of letters in the name Tim would be 3. This is because, again, it would get the number 20 and it would subtract it from the number of letters in the string, which is 3 characters. And that's how. This is a way to. This is one of the uses for using strings, and compared to other ways. So pointers. Pointers are literally just a pointer, like as in it points to something. So if you have a pointer to an array, it's technically just the array. So changing the pointer also changes the array. But I think it's easier to use the pointers than something rather than whatever you may be using. It's the most efficient way to do this. The pointer would be the address of the value, and the value is using the address itself. Using a pointer has a different address, but inside of it has the memory address of the value it's pointing at. That's basically what call by value and call by reference is, since it's involving pointers. Boom. Pointers are sort of complex, but they're really useful because it eliminates a lot of extra work you can put into stuff. So we start off with int main, int v equals 3, and we have the function 1. Now function 1 basically gets the address of v, or whatever number is in v, so which is 3. So it's gonna, and this and sign is basically with the v, it's gonna give the address of whatever is in here. So what happens is v equals 3, so it's gonna see out v, which is gonna be 3. What happens next is it's gonna make a new line, and it's going to output the function. And in this case, it's going to output the address of v, which is going to be the address, but then it does v equals v plus 1, and v is 3, so 3 plus 1 is 4, and it will return v as 4. So in this case, v is now 4, calling from the pointer from earlier. So now when we do cout, it'll return the address of, and then we'll also do 4. And now the cout v at the end will do the same thing as the one earlier, but given that it's not in the function anymore, it's going to return back to the original value, which is 3. So if we were to run it, we would do pointer, and then we would just run it. And as we can see, we have 3 on top because of the v, and then we have address of v, which would be the address itself. Then we have the v equals v plus 1, which would be 4, and so it returns v, and which is 4. So we have the 4 on the bottom, and then again cout v, which would be 3 because of the original. And that's basically how the pointers work. I'm pretty sure what happens here is it takes, rather than going from this and putting it to this, it takes the v from the address itself, and it just takes it, and you can basically do it without calling for extra stuff because it's pointing at this one itself, the value. And you can do things with them, but it doesn't ultimately change everything else when it gets down to this stuff. Let's talk about structures. So C++ structure is a collection of different data types. So like you have a group of variables inside of it, grouped up. So rather than having a list, like having a group of variables, right? Like int this, int that, and all that, and it's under a certain group. Say a house. You have a house and it has different characteristics that follow it. So say it has a paint color, the size of the house, how many floors it has. So now rather than having a int or like a character or a string for each and every characteristic, and you have to keep calling it by the full name. What you can do is you can categorize that to a smaller phrase. So if it's house, say letter H. So if we're talking about the size of the house, it'd be h dot size, and we would be able to pull the number that's been put for the size of the house from the structure or the group of the characteristics from the house. So in the same way with this, what structures basically do is they can allow you to take in information from a group of similar or corresponding ideas, and then lets you put them in from the group rather than having to put the full thing out. So this would be really good for organizing or compressing how much stuff you have on the code in general. This can be seen similar to arrays, but the difference between this is the structures are user-defined data types, which are used to store groups of items of non-similar data types. So what this basically means is rather than having everything just being char or int at the same time, you can pull data to have different types such as int, double, some char, string, and so on. The next one will become sorting. So basically, it's sort of like an algorithm, and in this algorithm, it basically puts the elements of a list in certain orders. That's literally what it is. If you want to go from the smallest to biggest, and you can go from smallest to biggest, or vice versa, biggest to smallest. But it doesn't work just for numbers. If you want to do in words, you can go from alphabetical order, backwards or forward, and then you can also do it in specific ways other than those at all. Maybe you want to do it in a specific order, and that's how it is. It allows you to be more flexible than just using like an if this or a while this is this. It gives you the accessibility to do this. An object has states and behaviors, so they have different um, stuff inside of it. What objects are is they basically are created from a class, and we declare the objects of the class when we with the same sort of declaration as a variable type. So basically what happens is we're in the class, um, we class with the same. What happens is we basically declare the stuff inside of the class. It's the actual variables itself, the actual values, because in classes. So if you go to classes, the classes used to specify the form of an object, and it combines data representation and methods for manipulation or manipulating that data into one neat package. So the data and functions within the class are also called members of class. What basically this means is it defines the object without an actual value data. So rather than having um, um, say box one, it has like the length, width, and height. Rather than putting the actual values, like oh maybe it's 20 centimeters, 30 centimeters, and 40 centimeters. It's just the actual parameters itself, not well like the characteristics. We use the objects itself to give off the actual values itself. That's what it is. Then we go to access specifiers, and a derived class can access all the non-private members of its base class. Thus, base class members that should not be accessible to the member functions of a derived class should be declared private in the base class. I think this means it basically controls whether or not things can be accessed by um, different I guess statements around the code. It controls whether or not so basically it controls whether or not it can have access to it, which means you got to call from other parts. I guess it locks things down, so things can be used, things can't be used. That's what basically it is, I guess. For constructors, a constructor is a member function of a class which initializes objects of a class. So in C++, constructors are automatically called when objects are created, and it's a special member function of the class. Cool. We have an inheritance, and what it basically does, it defines a class in terms of another class, which makes it easier to create and maintain an application. What basically happens is once you define something as something, you can relate it to something else, and it would if it's has similarities from the things before, they're basically the same thing. That's what it is. The example I saw earlier with the like how a dog is a mammal and it's an animal and all that, and basically it relates to the original one. How if it's one to one, then the other one goes to the other one. It makes sense. So if you have similarities between one thing, they all connect. Overloading is a feature where if you can have two or more functions that have the same name but have different parameters or different they have different things they can do. So that's pretty cool. There's two more, and that would be file IO and binary search. So what file IO basically does is you can create, open, or close text or different files and access their storage. This can be useful if you want to write things from the actual code itself to a text file. Say you, or if you want, you can also take the data from the file. Say you have a list of names and GPAs, and you want to rank them up. You can do that. Or if you have numbers, say movies, you have the box office. You can see how much money each of them make, and basically what you can do is you can sort them from the highest grossing to the lowest grossing if they're all in the file, and if they're not already organized, which is really useful. You also have binary searches, and what this basically does is it, say you have an array. What happens is, and you have like your certain range, so say 0 to 10. So what happens is, if you have a number you're looking for in specific, what it does is it's basically breaks it in half, and it then breaks it in half over and over again until it gets to a specific part. So from 0 to 9, if it's something in the first half, so if it's not in the first half, what will happen is it will check the second half, and if it's from the second half, it will split in half again until it gets to the smallest part where it's the actual thing you're looking for. And if it's not there, well, then there's nothing there. That's basically what binary search is. It's not really complex.